We're solving a quadratic equation and a linear equation here, but the answers are going to be complex numbers. We're also asked to show detailed reasoning, so we've got to make sure we're really careful and don't, you can't just put this in a calculator, for example. Got to show where it's coming from. So for the first one, we've got a quadratic, and I would go ahead and use the quadratic formula. I don't think you particularly need to state it. We can just use it, so it's going to become minus 10 plus or minus 10 squared, which is going to be 100, minus 4ac all over 2a. And 4 times 25 is 100. 100 times 2 is 200. So actually this is going to be the square root of minus 100. And that you can write as, I'll just do it over here. You can write it as a square root of 100 times the square root of minus 1. So it's equal to 10i. Now we're nearly done, but it's asked us to leave it in this form, a plus bi. So I can write it as 10 over 4 or 5 over 2 if I'm simplifying it. Then it's going to be 5 over 2i, or 5 over 2 minus 5 over 2i. So that's our answer to the first question. For B, I'm going to start by expanding that bracket, I think. Five I plus 2i omega. And I'm trying to solve for omega. So things to do is collect the like terms. So get your omegas on one side, get your numbers on one side. So first, I think I'm minus 2i omega. And I'll add 2 to both sides. Factorize out the omega. Sorry, that should have been an equals sign. Hopefully you spotted that. It's actually very much like you're solving, a normal kind of equation with x on both sides. It's just we've got to be careful because we've got these imaginary parts. So omega is equal to 2 plus 5i all over 3 minus 2i. Now, we're not actually done here because, again, we're being asked to leave it in this form. So we've got to divide these complex numbers. And this can be done by timesing through by the complex conjugate. 3 plus 2i divided by 3 plus 2i. So essentially I'm timesing top and bottom by the same thing. So I'm not changing anything. It's absolutely fine. And now I can multiply out these double brackets. So I'm going to get 6 plus 4i plus 15i. And then it's going to be plus 10i squared. It's actually going to become minus 10. And here's the reason we've just done that, because now when you multiply the bottoms, we're going to get 9. And then we're kind of exploiting this idea of the difference of two squares. We're going to get plus 6i and minus 6i. So you don't need to write that in. It's just going to become minus 4i squared, which is plus 4. So that's really good because we've got rid of the complex number on the bottom. Just combine the terms, so minus 4 plus 19i over 13, and we're nearly there. It's just it did ask for a very specific form, so it's minus 4 over 13 plus 19 over 13i. That's the form that was asked for.